I would like to welcome everybody to our next C-Suite session here at Microsoft booth. And for this one, I have two amazing leaders, Roland Busch, CEO of Siemens, and Uli Homann, CVP of Engineering at Microsoft. Gentlemen, thank you for coming and being here with me.
Thanks for having us.
Thanks for having us.
And I was really looking for this conversation. This is the highlight of my day because we're going to talk about physical AI, and this is where the future of AI in my mind really resides. And I want to start us with a question just to ground us in this subject. And Roland, I'm going to ask this to you. Just tell us, what is it? How should we think about physical AI?
Well, I mean, if there's physical AI, what's the other part? Call it maybe consumer AI, so just to differentiate, to start with. So what's the difference? And I'll give you one example, which you can also see when you visit our booth, and then I give you a little bit of context. Think about, and on our booth, we showcase how to manufacture a personalized shoe. So it's a sneaker. So it starts that you stand there on a pad, it measures your feet, then it translates it into a sole, into a shoe, and then it's manufactured according to your specification, a little bit stronger on the left side or right side, depending what you want, and the whole thing goes all the way from the design of a product all the way to manufacturing. In order to make that work, you need industrial AI. It starts how to translate the footprint of your foot into a kind of a structure which you manufacture, how to manufacture that in all the way. So this is really when AI hits the shop floor. Once the shoe is then in the store, if people want to know, I mean, there's a customer coming in, what he normally demands, what color. This is another kind of AI, which is really about your personal preferences. When you're a frequent buyer, you will go get that. So in that case, if they say, oh, you like yellow shoes, and you say, no, today I'm more into green, no problem. However, if on the manufacturing side, I print a shoe and it just doesn't fit you, it's maybe 2 numbers too small, that does matter. So, and physics AI is really that you cannot allow hallucination. Number one is it really affects the real world. It changed the real world. And it really does something which is on a completely different level of quality expectation. Now, a little bit of context. Most models are trained on language. Mm-hmm. These are the reason why they call it large language models, maybe on numbers. These models didn't see everything what physics AI needs. They didn't see these data yet. Time series data, design data, visual inspection data, any kind of data which are physics related. And these data have different context. I mean, for the texts, I think the models, the large language models, they got it. If you have a sentence, what's the next word? Somehow they got it because they got the context. The context of the industrial world is not there yet. How does a piece of a part of a machine relate to another one in a very complex machine? No idea. So you need to train the data, the model on the industrial model on these data, and then you can bring it to the context to be really super precise. And that makes a big difference because it really changes the way how we manufacture, how we design, how we operate.
Because the context changes. It's no longer a language context. It's the context
Exactly.
of the physical reality that we are dealing with. That's a different way to think about it. Uli, do you want to comment on this one?
Well, I would add to this where at the end of the day, what we're looking at is the fusion of intelligence with process and design. To start at the design side, and then you end up in the process side, and we put intelligence in there. And that's fed by data, it's fed by process understanding, and then it's fed by dynamic decision making, which we have done. But if you write code to make these dynamic decisions, you have to foresee every possibility. And with physical AI or AI in the physical world, we're now starting to see that the system will understand the scenario, look at the real world, physical, and then make a decision. And that's not something that normal software does. And that's really the big difference between AI-driven process manufacturing and standard process manufacturing. And I think that's going to be where we will see a lot of innovation, because right now we are, for example, relying on people to make up the flexibility angle. But if you have no people in the factories anymore, or people that don't really know what they're doing, we're working with one customer, their overturn of operators is 6 months. So they have a person there for 6 months, then they're off, which means they have no idea what they're doing. Therefore, you have to have intelligence in the system that can make up for the intelligence or the experience that's not there anymore. And I think that's the other half of where process manufacturing and physical AI come together.
So AI is already bringing a lot of change into how we think and operate. Physical AI takes it to the next level. You need a new model, new way of thinking about the world. You need to include processes into it. That's a lot of change for everybody involved.
Yep.
When I see this much change, I'm thinking, what's the first thing? What's the really most important in dealing with it? And then I think about you gentlemen, because I think it's leadership. So, Roland, how do you change your leadership? How do you lead your team and help them deal with this transformation?
You go first.
I knew he would do that to me. I think Roland actually does it well, but Satya does it well as too, is you lead from the top, meaning you show that you actually live AI. Roland, I heard you built your first agent yourself.
Sure.
So that's something that I think everybody...
I would not release it to the shop floor yet, but anyhow.
But you did it, which means for me, you show leadership, that you embrace the capability and you show that it can be done. Because a lot of people will look at you or me or Adam, say, if you don't live it, why should I do this? So that's where it starts. The second thing is, especially with generative AI, Roland already mentioned it, it's not deterministic. Therefore, we have to have a very strong governance model in place to make sure that the intelligence that we want to apply stays within the guardrails that we set. And a lot of enterprises take this not serious enough from my perspective. They talk a lot about it, but then there's a lot of POCs, use cases being built without it. And I personally think that's a little bit of a problem that I would love us to avoid, because if we put the right foundations in, we can then apply a lot of AI without really the risk going up. I think that's the second element. And the third thing is we have to give people the opportunity to use these capabilities. I see a lot of companies where, let's say, technologies like Microsoft Copilot are only given to N% of the organization because they need it. The other guys don't. If you really want an AI-based transformation, you have to give the tools, whatever they are, to everybody, so that they can advance, they can learn and apply it to their jobs. And most likely you will be surprised because the people are smart. Once they figure out what these things can do, they will achieve amazing results. And I think if you combine leadership, governance, and then access to the capabilities, you will see a lot of advancements in your organization in the transformation that AI ultimately represents.
So, and just to add, number one is showing from the top that you're embracing technology is super important, because very often your organization mimics what top leadership does. But the most important point, I guess, is that to make people aware that, I mean, AI is a technology which is not go away. The genie is out of the bottle. It will do whatever it can do sooner than later. Which
is actually creating its own genie now.
It's their own genie. Genie creates its own genie. So, but the first thing is to make the people aware. Unlike all the other fundamental transformations like electricity or where the computer, the internet evolved, this one is 2 times faster than the last one, and maybe 4 times faster than that one before. So I say 7-8 years, and it will fully penetrate everything what we do. 3 already gone. So think about it. And if you think about the step up, what the models did over the last 6 months, you know what I'm talking about. How can you measure that in a world where you say normally the change in technology is your working lifetime? Now it's not. Now it's just a fraction of your working lifetime, and it has to happen now. So then people tend to say, oh yeah, transformation is great. You transform first and I follow, or my department follows. No. This is not the point. You need to do that now, and you have to be sure that whatever you do today, unlearn a part of it and learn something new, because it will change fundamentally. which brings me back to the question, what remains then for the people? And it's a lot of things, creativity, contextualization still, I mean, all the experience which we bring, the humanity in something. So it's a lot of things which we have to focus on while learning new technology to stay relevant in the future. My workforce, we talk about, I mean, I think less people, no, maybe similar amount of people without, so in total 320,000. If I take Siemens Healthineers aside, 250,000 people. I know that most of them will see in the next couple of years a different way how they work, and they better start learning now and giving themselves into it in order to stay relevant. And to take the people along and not saying, don't worry, nothing happens, we don't lose jobs. Yes, we might lose jobs in that corner, but we build new jobs in another one. So it's about growth. It's not about cost savings. That's a part of it. You can eliminate repetitive processes and throw models on it, but it's really about driving higher growth. That's what I believe what we can do together in our partnership. We showed it already, and that's super relevant. Last point, minor detail. When you then talk about budgeting, and people say, no, I budget a person head count, don't forget, if you forget budgeting tokens, you miss the point.
Yes.
And secondly, if people say, oh, I limit my budget for tokens, and say, no, that's not a good idea. You should say, go, because the more tokens you consume, hopefully in a meaningful manner, the more you know now AI is working in our workforce.
And we are building AI factories here in Germany together with you.
Exactly.
In North Rhine-Westphalia to provide you with the tokens.
Exactly.
Tokens in place. And normally when you think about, because this is future, what you're describing is really the future of what's going to happen to all of our jobs. Normally when I think about the future, it's sometime in the future. But not this time. Now the future of physical AI is really happening almost in real time. It's in front of us. So my next question, I'm going to start with you, Roland. What is the future of physical AI? And is it really today or is it far in the future?
I think my glass bowl is not better than yours. So therefore, it's super hard. It's super hard to say what happens in technology, which surprises us every 6 months. But let me give you one example, which is very hot, also on Hannover Trade Fair. Let's talk about humanoids. When I'm asking, when will a humanoid be ready to say, you get one at home and it does whatever you don't want to do? I mean, ironing, folding, cleaning up the room of your children and all that stuff. I would say, before that we said, oh, that's really complicated. 10 years from now, I do believe that the timeline shrinks because the learning of the models is accelerating. And it's unlike we learn. I mean, I learned something. I unfortunately cannot translate what you learned into my brain. Unfortunately, because I know that you're a smart guy. But for robots, you can. You can train a brain on a robot, and then you multiply it, and you can add on it. So therefore, this is really exponential. So when will it be that you get robots at home which do everything what you want them to do, cleaning up the room of your children? I would have said maybe 10 years from now. That can be 5 years. It's not so near, but it can be in 5 years. Only thing, if you do have children at home, watch out. If this robot is really smart, it learns very fast, and after half a day, it starts taking the children out of the equation rather than cleaning up the room. But anyhow.
Uli,
Actually, I was thought that you would say that the children are now the boss and they do whatever the children want because they can program the robot and the mother or the father cannot. But okay.
Uli, your take on how far the future is really for us.
Well, actually, I don't know about the consumer side. Maybe Roland's point of 5 years is a good one. But we're already seeing new advances in robotics are happening in the factories. So most factory robots have single arms right now that they operate. We're now seeing robots coming out with 2 arms. So they mimic human behavior much better than the single arm systems. They might not be mobile yet, but they do have multiple arms. And Microsoft, for example, built a robotic foundation model called RoAlpha for exactly this scenario, for 2 arms.
2 arms.
Sensing and all those kind of capabilities. So I think in the industrial space, you will see the advances over the next 18 months go very quick. And you see it all around here. The humanoid work on industrial robots, I think, will also go faster than consumer robots. The consumer robot, I think, is an interesting market given the demographic change that we're all seeing, especially in the Western societies. So helping help at home for elderly people. I'm an elderly person, so I might need help soon. And so from that perspective, I'm looking forward to that future. But in the industrial space, I think it's going to go very fast. And the thing that I'm worried about, coming back to governance and infrastructure to manage all this stuff, a lot of factories are not connected yet. If you're not connected, you can't get these multiplying effects of intelligence being built in one place and then growing by the data across every other place and making it smarter. NIST, for example, out of the US, they are saying now severity 0 patches needs to happen in 48 hours. If you are in the manufacturing business, would you confidently say you can patch your factories in 48 hours? I don't think you can, but we need to get there. And especially going to be important once we could put AI into those systems, because AI is dynamic, and therefore we need to be updating it much faster than what we are used to. Used to factories shut down on Christmas, that's when we do the software updates, right? We can't do that anymore, so we need to find a path where we can harness that innovation that's happening, but do it in a safe and manageable fashion. And therefore, partnering around connected strategies with Project Margo, the Open Process Foundation, OPC Foundation, those kind of things, is really important so that we set the standards and enable the customers to not only embrace the innovation, but do it safely.
Uli, thank you. Roland, thank you so much. Thank you for the conversation. Thank you for being here with us.
Adam, thank you.
Great pleasure. Thank you.